Hi folks, today we're going to be looking at some problems involving exponential functions. So without further ado, let's get started. Which of the following functions correspond with the graph given below? So we have a graph that's decreasing from left to right, and then we have our options are f of x equals 2 to the x minus 3, g of x equals 4 raised to the x minus 3 power, h of x equals 1/4 raised to the x power, and then we subtract off 3, q of x is 1/2 raised to the x power, and then we subtract off 1, and then r of x equals 1/2 raised to the x power, and we subtract off 3. So when you look at this, right out the gate we can eliminate some of our options. And the reason why is our graph is decreasing. So when you look, our graph's decreasing, so that means anything greater than 1 is not a possibility because that would indicate an increasing graph. So we can eliminate f of x and g of x before we do anything else just by noticing that this graph is decreasing. Okay, so we have values, it must be between 0 and 1. So we have h of x, q of x, and r of x are going to be our three values that we can kind of look at now. Now the next component that we'll look at is this horizontal asymptote. So as you approach positive infinity, notice there's a horizontal asymptote at y equals -3. So that means we have a vertical shift down 3 units. So doing that means we're going to subtract 3 outside of the exponential function part there. So that means we have a -3 appearing at the end. So we can eliminate q of x. So we're down to h of x equals 1/4 to the x minus 3 and r of x equals 1/2 to the x power minus 3. And now we'll need to actually use some points on the graph. So at this point we could try and use the point, notice you have 0, -2, but when you plug that in, plug it into h of x for example, you plug in 0, you get 1/4 to the 0 power, which is 1, minus 3, which is -2. And then if you do the same thing for r of x, plug in 0, you get 1/2 to the 0 power, which is 1, minus 3, which is -2. So both of those line up with the graph. So the actual point that we'll use is this -2, 1. And we can plug it into our equation. You have a couple ways to do this. So we can just plug it into both since we have options here. But let's say we didn't have a list of options. We can actually find this value out, right? So what we do is we plug it in. And what that means is if -2, 1 is on there, that means 1 equals b to the -2 minus 3. Okay? And so how do we solve from here? Well, first add 3 to both sides and you get 4. By the way, you could write that 1 over b squared minus 3 if you like that. But at the end of the day, we get 4 equals 1 over b squared. So now where do we go from here? Well, you can multiply both sides by b squared and then divide both sides by 4. So you get 1/4 equals b squared. And in order to solve this, we take a square root of both sides. And usually you have a plus or minus. But the reason we don't is since it's an exponential function, we only consider the positive versions of these square roots. So the square root of 1/4 is just 1/2. And we have our solution that this has to be 1/2 to the x power minus 3. Okay? And as I mentioned before, you could just plug in -2. If you plug it in at 1/4 raised to the -2 power, notice that's actually 16 minus 3, which is 13. That doesn't match our number 1, which appears in the y-coordinate. So we know that we could eliminate that choice as well. So a couple different routes for finding the solution, but hopefully that helps us gather how to solve when we're given a graph, find the actual equation to that graph, as long as we recognize it's an exponential or transformation of an exponential function. Okay, moving on to the next question. Determine the domain and range of the function f of x equals 8 to the x plus 1 power minus 9. So domain, notice that's the values we can plug in, so that isn't going to be too bad. Well, you can plug in any value into the exponent, it's not going to cause any problems. So since any x value can be plugged in, that means our domain is actually -infinity to positive infinity. So now the range. Well, let's think about what usually happens with the range. And what's happened to this graph? Well, if this was 8 to the x, right, then we would end up having the range being from 0 to infinity, where 0 is not included. But what we've done to that graph is we've shifted to the left 1 unit, which doesn't have any effect on our range whatsoever. But down 9 units, that will have an effect, because remember the up and down is our y values. That's our range essentially, what y values are getting hit. So at the end of the day, what's happened? Well, horizontal has no effect. The vertical shift causes our range to shift by 9 units down, essentially. So instead of 0 to infinity, if we're shifting down, that's essentially like subtracting. So we get our range is actually -9 to positive infinity. Okay, moving on to our next problem. Solve for x in the exponential equation 4 to the 7x minus 1 equals 8 to the 5 minus 3x. How do we go about doing this one? Well, the first thing that we need to do is get the same base. So what's the same base if possible here? Well, notice 4 and 8. 4 is in the power of 8, 8 is not a power of 4 right away. That's immediately evident, I should say. So the fix for that is, notice 4 we can write as 2 squared, and 8 we can write as 2 cubed. And so since they're 2 to a given power, we have this is 2 and then raised to the 2 times the quantity 7x minus 1 power, and then that should equal 2 to the 3 times the quantity 5 minus 3x power. Now, since the bases are the same, we can use this one-to-one property of these exponential functions, and we get the fact that the exponents must be equal. So 2 times the quantity 7x minus 1 equals 3 times the quantity 5 minus 3x. And so now this is just a basic linear equation, and we can go about solving it with the methods that we already know. So we get 14x minus 2 equals 15 minus 9x, and that comes just by distributing the 2 on the left-hand side and the 3 on the right-hand side. Okay, moving from there, we got to get all the x terms on one side and all the constants on the other. That's how we solve our linear equations. So we get 23x equals 17. The way we did that was we added 9x to both sides, and then we added 2 to both sides. So kind of doing 2 steps at once there. So you get 23x equals 17, and our final answer is x equals 17 over 23. All right, so let's move forward, see another problem. Let's get into the word problem side of things here. So Jordan Gecko wants to purchase a new vehicle in 5 years for $30,000. If Jordan finds a CD that compounds quarterly with an annual interest rate of 4.25%, then what initial investment should Jordan put into the CD in order to accumulate $30,000 after 5 years? Round your answer to the nearest cent. So we first have to think, what sort of formula are we going to be using? And since you see this compounds quarterly, that should be a big indicator that, hey, we are using the compound interest formula. So keep in mind we're using that A of t equals P times the quantity 1 plus R over N raised to the nth power. All right, so now we need to find what are we looking for, what are we actually dealing with here. We want to find the initial investment. So that's going to be a little bit different than our usual case. So since we're finding the initial investment, that's actually our P value. So just an FYI, what do all these things mean if you don't recall? We have A of t is the amount, the total amount after t years have passed. So in that case, it's going to be $30,000. P is the initial investment. That's what we're looking for here. R is the annual interest rate. So if you look, we have 4.25%. So you'd write that as 0.0425. And then N is the number of times compounded per year. So if we're compounding quarterly, that's going to be 4 times per year. And so we have that all these values pop up, just as we mentioned before. And our T value is the only one that has been missing from what we just stated. And it's 5 years, so we have all that information. So now we could set up our equation, right? And we're looking for P. So what do we have to do at the end of the day? Well, that whole thing on the right-hand side is just some number. And we're going to have to divide by that number. Now, if we list it out, you could write that, if you plug it into a calculator, you get 1.235380509, so on and so forth, right? Make sure you don't round too soon on these things. So you want to keep the full decimal displayed, and so you can make that calculation at the end of the day. So now, solving for that right-hand side, what do? Well, we divide both sides, that number that appears on the right-hand side. If you wanted to leave it as the value in parentheses and divide by that whole quantity in the step above, that's fine too. It doesn't really matter, but a lot of people like to just write the decimal down and do it that way. So that's what we'll do here. So P is technically this is approximately 30,000 over that 1.2353, so on and so forth. But what does that equal? And it's approximately $24,284.02. Now, we should also do a check. And what do we mean by that? Well, does this number make sense? Okay, so notice we want to finish after 5 years with $30,000. And so does $24,284.02 to start with make sense? Yes, it's a lesser value, and it increases to get to that 30,000, right? So you can tell kind of, there's always some checks. I've seen some answers before where people say, oh, it's $1 million is our initial investment. That wouldn't make sense in this case. You always want to go back and check, does this number kind of make sense in terms of our final answer? So in this case it does, and it is our actual answer here. Okay, moving on to our next component. So Peggy and Sue are arguing over which option is the better way to invest their money. Peggy found a 10-year CD that compounds daily with an annual interest rate of 3%, while Sue became aware of a 10-year CD that compounds semi-annually with an annual interest rate of 3.1%. After a brief argument, Peggy decided that the CD compounded more often would be better investment, and Sue mentioned that her CD with a higher interest rate would produce more money after the 10 years. Soon both Peggy and Sue wish to leave their initial investment and interest in the CD for all 10 years. Which person has the better investment option? So, in this case, this is actually more of a real-life scenario. You'll be given different options, different investing amounts, and usually time frames too. So it doesn't have to always be a 10-year CD with these different interest rates, different compounding times. But we want to make our best investment choice, essentially. So what's the best investment choice? Well, let's take a look at Peggy and Sue's values. And what are we using here? Well, it's the compound interest formula, once again. So that's that A of t equals P times the quantity 1 plus R over N raised to the NT power. How can we tell it's the compound interest formula? Well, when you notice it says compounds, and then we have semi-annually, and then we have another one that's compounding, what is it, daily, I believe? Yeah, compounds daily. So we have those two values. That's telling us a compounding time. That's why we use our compound interest formula. All right, so where do we move from here? Well, it's just plug and chug time in terms of our values. So in Peggy's case, what do we get? Well, Peggy, if you notice, found a 10-year CD, so that 10 represents the time, T. And then you have the daily interest rate, daily with an annual interest rate. So it's compounded daily. That means that's 365 times a year. And some of you might say, oh, well, it's 366. Technically, it's 365.25, but we'll just put 365 for simplicity's sake. It won't make a difference with that extra quarter of a day that actually occurs. So we have that, and our annual interest rate of 3%, so that's 0.03. So we have all those values plugged in there. What does this give out as a number? Notice we still have P in there, so it's going to be whatever the initial investment Peggy chooses, we'll still have that P involved. So this is P times 1.34984. Okay, so let's take a look at Sue's investment. So Sue, if you look, where do these values come from? Well, notice she chose the higher interest rate, so that's where the 0.031 comes into play. However, it's only compounded semi-annually, so since it's semi-annually compounded, that means 2 is our value. Semi-annually means twice a year, and it's still a 10-year investment. So when we plug in all those numbers, what's being multiplied by P? Well, that's going to be 1.36019. So notice we have P in both cases, but we're multiplying by different values. And you want to choose, if you want a larger number, you want to choose the number that's the greatest to multiply by P. So in that case, if you notice, Sue has the larger number with the 1.36019, and so that means Sue has the better investment option.